Bismillahirrahmanirrahim. Unit 15, Electromagnetism Conceptual Questions. This is Book 10, National Book Foundation. And since this topic is covered in the second year physics as well, so from the conceptual point of view, this is equally good for the second year students as well. So they can also benefit out of the conceptual questions from this video. Question 1. Two parallel state conductors carrying current in same direction attract each other. Explain why. And the second part of this question is, what would you conclude if the direction of the current in the conductor is opposite? Now, first consider two parallel state conductors 1 and 2 carrying current I in the upward direction. According to right hand grip rule, the curl of the fingers shows the direction of the magnetic field around both the conductors. This is the curl of the finger, and here in this case it shows the direction of the magnetic field in counterclockwise direction. In both the cases, one looking from the top of the conductors. Now notice that magnetic field is out of the page on the left and it is into the page on the right side of the conductors. And due to conductor 1, the left side is the region between the two conductors, and for the conductor number 2, the right side is again into the between the two conductors. So what happens is this region, the magnetic field, cancel each other. Since it is opposite to each field, so it weakens. So this field gets weakens, and notice that the magnetic field in the interior of the two conductors oppose each field, and it cancels, weaken the field between the two conductors. On the other hand, the bigger circles here will again enter in this region and it will strengthen the field outside. Similarly, this bigger circle of the conductor 1 will emerge out in this region and it will strengthen the field here. So magnetic field will be strengthened in the exterior of the two conductors, and it will be weak magnetic field between the two conductors. That means the fields in the exterior of the two conductors will be responsible for the forces. It is the magnetic field on the exterior of the two conductors that is responsible for the electromagnetic force on the conductors. The direction of the force can be ascertained using the right hand palm rule or Fleming's left hand rule. I use the right hand palm rule here on the conductor 1. If fingers point into the page in the direction of magnetic field and thumb in the direction of the current, the palm will give the direction of the force, which in this case is towards conductor 2. Similarly, on conductor 2, since magnetic field is out of the page, hence fingers point out and thumb still up in the direction of the current, the palm is toward the other conductor 1, hence both the conductors have attractive forces here. Second part of the question is, what will you conclude if the direction of the current in the conductors is opposite? I have conductor 1, current going upward. Now if the current in the conductor 2 is reversed, meaning current in both the conductors is opposite, note that according to the right hand grip rule, on both the conductors will have magnetic field emerging out of the page in the interior of both the conductors. This right hand grip rule, fingers come out from the surface, that means magnetic field is coming out here in this region. Similarly, on conductor 2 as well, fingers come out in this region, so magnetic field is coming out in this region. Both these fields magnetic field of conductor 1 and magnetic field of conductor 2 will strengthen each other in the interior of the two conductors. The magnetic field on the exterior will weaken each other field because this is going in and this is also going in. Now, because of this field, the bigger circle will come up to this, and once they cross this conductor, the bigger circle, they will weaken this region. Similarly, the bigger circle of conductor 2 will weaken this region. So the magnetic field on the exterior of the two conductors gets weakened. The magnetic field on the exterior will weaken each other's field, means field between the conductors will be responsible for the electromagnetic. Only this field will be responsible for the electromagnetic force. Now, applying the right hand palm rule in both the conductors, the fingers will point outward in both the cases. Thumbs will point in opposite directions. One thumb is up, current is up, the other thumb is down, since current in the conductor 2 is down. So both the forces will be repulsive forces and will point outwards. So that means that if the currents are opposite direction, the force will be repulsive. After this, all this explanation, I must give you the wording for the concise answer to this question. The concise answer is, when two parallel straight conductors are carrying current in same direction, the magnetic field between the two conductors cancel each other. Hence, only the magnetic field developed on the exteriors of the two conductors will be responsible for the electromagnetic forces. Using the right hand palm rule of the forces are attractive. And when the conductors are carrying current in opposite direction, the magnetic field in the exterior of the conductors oppose each other's field and become weak, whereas the field between the two conductors gets strengthened. Since currents in the two conductors are in opposite direction, the force due to same field is repulsive. Now, question number 2. Bar magnets are dropped simultaneously in long pipes of same length, but one made up of plastic and the other is made up of copper. Bar magnet comes out later through copper pipe than the plastic pipe. Why? The bar magnet that is dropped in the plastic pipe falls with the force of gravity, that is its weight with acceleration equal to g is equal to 9.8 meter per second square. Recall that a changing magnetic field induces a current in the nearby conductors. This induced current always produces a magnetic field. The induced magnetic field is always opposite to the field that caused this current. The bar magnet that is dropped in the copper pipe induces a current in the pipe that causes a magnetic field opposite to the field of the bar magnet. This opposing field causes an electromagnetic force which opposes the gravitational acceleration, hence reducing the gravitational acceleration. This reduction in acceleration causes a delay in the fall of the bar magnet in copper pipe. So in the plastic pipe there is no such magnetic field, opposing magnetic field, whereas in copper pipe there is an opposing magnetic field which causes a delay. Now question number 3. What is the direction of magnetic force on this current carrying conductor placed in the magnetic field? Also label the diagram with current, magnetic field and the force. The direction of magnetic field from north to south is given as, these lines show the magnetic field from north to south. Current flowing through the conductor is in upward direction. This is a conductor, the current flowing is in upward direction. And using the right hand palm rule, point the finger in the direction of the magnetic field. fingers in the direction of the magnetic field, that is from north to south. Thumb points in the direction of the current. For the given figure, notice that when the fingers point from north to south and for magnetic field and the thumb in the direction of current, the palm points down, that is the direction of force is downward. This is the label for the force, for the magnetic field and for the current in the diagram. So that is how you will establish the direction of the current in this case. Question 4. What is the direction of rotation of coil shown in the figure when switch is closed? This is the switch, it's open switch at the moment. Label the diagram with direction, forces forming couple and rotation of coil. Now here in this coil, the rotation will be clockwise. The coil rotates clockwise. How? When the switch is closed, the current I from the battery is shown. Current is directed upward on the path in front of S pole and is directed downward in front of North pole. Using the right hand palm rule, if thumb points along the current I, this thumb points along the current I and fingers point from north to south, the palm will direct downward. Therefore, the force on the S segment of the coil will be downward force. On the other segment, that is the north segment, this is the north segment, the same current is directed downward. Since direction of magnetic field is same, only turn the right hand such that thumb now points along the current, fingers remain in the same direction, and in this case the palm is upward, so the force acts upward. Now the two forces forming the couple are shown here. The direction of rotation is clockwise direction.